Have you ever wondered how a shaft and a hole fit so perfectly together in mechanical assemblies, without grinding, jamming, or leaving excessive clearance that could lead to failures? Behind every perfect fit in mechanical engineering lies one powerful global standard, ISO 286, ensuring precision and compatibility worldwide. In this video, we'll break down ISO 286, covering what it is, IT grades, fundamental deviation, and the different types of fits including clearance, transition, and interference. ISO 286 defines tolerances, deviations, and fits for linear dimensions of machine parts like shafts, holes, gears, bearings, and keys. It ensures interchangeability between parts from different makers, accurate assembly without issues, global standardization across borders, and reduced manufacturing errors in various industries. For example, a 50 mm shaft made in India must fit seamlessly into a 50 mm hole made in Japan without any separate tolerance discussions, thanks to ISO 286. Let's start with basic terminology. Nominal size is the theoretical or ideal dimension specified on the drawing, like a 50 mm shaft. Deviation is the difference between the actual size and this nominal size, categorized as upper deviation and lower deviation. Tolerance is the total permissible variation, calculated as the upper deviation minus the lower deviation, such as plus 0.03 to minus 0.01 equaling 0.04 millimeters. Fundamental deviation is the deviation closest to zero, defining the position of the tolerance zone relative to the nominal size, like hole H where EI equals 0 starts right at nominal. IT grades, or international tolerance grades, indicate the size of the tolerance zone, with a lower IT grade signifying higher precision and tighter tolerances. For example, IT5 is for high-precision components like gauges and bearings, while IT11 is for low-precision structural parts like frames. ISO 286 defines IT grades from the finest IT01, IT0, IT1, up to the coarsest IT16. Generally, IT5 to IT7 are for precision machining, IT8 to IT10 for general machining, and IT11 to IT13 for casting or forging processes. For a 50 mm size, an IT6 tolerance is approximately 0.016 millimeters, meaning a 50 mm IT6 shaft can vary only by about plus or minus 0.008 millimeters, which is extremely precise. ISO 286 defines both hole basis and shaft basis systems, with the hole basis system being most common due to easier manufacturing when the hole's EI equals 0. There are three main types of fits. First, clearance fit, where the shaft is always smaller than the hole, allowing free movement. Examples like H7/G6 and H8/F7 for bearings. Next, transition fit, which can sometimes be clearance and sometimes interference for controlled tightness, ideal for gear hubs and couplings, like H7/K6 and H8/JS7. Finally, interference fit, where the shaft is always larger than the hole for permanent tight fits, used for press-fit bearings and railway wheels on axles, such as H7/P6. Let's look at practical examples. For a bearing fit like H7/G6, the hole's H7 tolerance starts at nominal with EI equals 0, and the G6 shaft is slightly smaller. This results in a perfect running clearance for smooth operation, commonly used in ball bearings and machine tools. For a gear hub fit such as H7/K6, a standard H7 hole with a slightly oversized K6 shaft creates light interference, preventing slip under torque. A press fit like H7/P6 involves a much larger P6 shaft requiring pressing or heating for assembly, seen in motor rotor shafts and railway wheels. ISO 286 ensures engineers can design assemblies with predictable performance, zero guesswork on fits, and international compatibility across suppliers. It also leads to reduced machining costs through standardization, high product quality, and forms the backbone of modern machine design. If you found this explanation easy and helpful, hit like, share with fellow engineers and students, and subscribe to Simple GAN. For more engineering concepts explained in simple English, stay connected. Thanks for watching.